Welcome back, everybody. We're going to be talking about the identifying growth, decay, classifying different types of equations. We'll look at a few examples, um, how to solve some exponentials. All right, first one here, we got three functions, and we're going to classify them as growth or decay. And what you want to look for is the number, the base of the exponent at each one. If it's greater than 1, it's growth, but if it's less than 1, it's decay. See how we have 1.05? That would make it a growth equation. On the second one, see how the base of the exponent is less than 1? That would make it a decay. Pay no attention to the initial amount or the exponent itself. We're just focusing on the base. And then on the last one here, we see that 10 is greater than 1. That makes it a growth equation. All right, and this next one here, which equations can be used to model exponential decay? All right, we're looking for ones that have the base of the exponent less than 1. Looking at A here, 2.1, that's greater than 1. So yeah, A is not going to work. Looking at the base on B, 0.28, less than 1, so B works. Looking at C, 1.21, that is greater than 1, that's not going to work. And then looking at the last one, D, 0.98, it's close to 1, but it's just a little bit less. So here, B and D work for exponential decay. The others, A and C, would model exponential growth. All right, looking at the next one, question says, which equation can be used to find the solution of 1/3 raised to the power of D minus 5 equals 81? All right, in order to solve these types of equations, you want the bases to be the same, and when the bases are the same, you're able to just focus on the exponents themselves. Right now, we just have 1/3 and you have 81. Well, what's the connection there? What's the relationship between 1/3 and 81? Well, I could rewrite 1/3 as 3 to the -1 power, and I'm still raising that to D minus 5. And then to have a same base as 3, if I take 3 and raise it to the 4th power, that's the equivalent of 81. All right, now I'm just going to use properties of exponents here and distribute that -1. So then I have D 3 to the -D plus 5 power is equal to 3 to the 4th. We can ignore the bases since they are the same. And now we have -D plus 5 is equal to 4. And that would correspond with letter B here. On this next one, we're actually going to solve for n. Notice 25n minus 3 power equals 5n plus 8 power. We need the bases to be the same. Let's rewrite 25 is 5 squared. And still being raised to the n minus 3 power. And the right side of the equation, we have 5 to the power of n plus 8. All right, this 2 can be distributed to the n and the 3. So now we have 2 to the 2n minus 6 power, n plus 8 power. All right, the base is 5, the base is 5. Since the bases are the same, we could essentially ignore the bases and just solve 2n minus 6 equals n plus 8. We're going to take away n from both sides, and we're going to add 6 to both sides. We're left with n equals 14. And that's how we can solve for n on this exponential problem. And finally, our last problem here says the initial number of views for a blog was 20. The number of views is growing exponentially at a rate of 20% per week. What is the number of views expected to be 4 weeks from now? Round your answer to the nearest whole number. Okay. We can go back to our formula here. Y equals original amount, 1 plus the rate as a decimal, raised to a certain power, which is time. All right, we start off with 20. The rate is 20%. So coincidentally, the rate of growth and the starting amount is the same. 0.2, and we want to know from 4 weeks from now. All right, and then putting this into a calculator, 20 times 1.2 raised to the fourth power, 41.472. That can round to 41. So we'll have 41 views after 4 weeks. All right. Thank you very much for watching. If you have any questions, you can put them in the comments below. Thank you so much. Have a great day.